Welcome back to my channel. Today, let's solve Leetcode problem 74. Search a 2D matrix. You are given an m by n integer matrix with the following two properties. Each row is sorted in a non-decreasing order. First integer of each row is greater than the last integer of the previous row. First integer is greater than its last integer of the previous row. Each given an integer target, return true if target is in the matrix or false otherwise. You must write a solution which is order of log mn time complexity. Okay, if this restriction was not present, then the simple brute force solution would be iterate to the entire matrix and check whether we have found the target or not. If we found the target, then straight away return it. If we don't found the target, we can return it as false. This approach would take a time complexity of order of n square, order of m into n, because it has m rows and n columns. We are checking each and every element in the matrix. Since the elements in the matrix are non-decreasing order in each row, as well as the first element is actually greater than the last element of the previous row, we can also say all the elements in the first column are also non-decreasing order. Okay, yeah. So since the elements has a property of non-decreasing order, we can think of applying binary search on this particular matrix. Okay, there are different ways to apply binary search. Okay, let me tell you all the approaches which has came into my mind when I'm trying to solve this problem. Okay, assume that all of these rows are present in a single row itself. Instead of imagining it as a matrix, think it as all the elements are present in a single row. If you see, I've just rearranged them into a single row. Okay, so now this all the elements are in non-decreasing order, and this boils down to the regular the routine binary search where you can search for a target in the given array. Okay, so we will be checking the mid. Initially the left will be pointing to the leftmost index and right would be pointing to the rightmost index, and then we will be calculating the mid and comparing mid with the target and taking a decision whether to go into left half or right half depending upon the target, right? Now, since these were not present in a single row, rather than it was broken down into multiple rows. Okay, given the mid, okay, let's have the mid value. Okay, how can you identify that mid belongs to which row and which column? Okay, so I can say, since each row contains m columns, right? So the row which mid belongs is actually mid divided by the number of columns. Okay, this would give you the column which the mid belongs to. Okay, where mid is actually left plus right divided by 2. Okay, now that we identify the row that mid belongs to, we should also identify the column which mid belongs to. Okay, so we can identify the column that it belongs to by doing the modulo operator, right? So let me give an example. Let's say mid is equal to 4. Okay, so 4 divided by 4 will give you 1, which will tell that I belongs to the first row, right? And 4 modulo 4 will tell me that I belongs to the 0th column. So 0, 1, 2, 3, 4. So mid is 4 here. Okay, I'm talking in terms of indexes. Okay, once you find out an index, in order to identify which row it belongs to and which column it belongs to, all you have to do is to divide it by columns in order to give you the mid, and take a modulo operator in order to give the columns, rows and columns. Okay, which row it belongs to and which column it belongs to. Now that you identify the mid, the cell which you want to actually look at, right? Now you can again apply the regular binary search algorithm. If the mid is actually greater than the target, that means you have to eliminate one half accordingly and then look at the other half. Okay, so this is what the algorithm would look like. Okay, so where we are actually iterating in a single go and then making a decision whether we have identified a target or not. Okay, I have defined left is equal to 0 and right is equal to the rows times the columns minus 1. That means the last element which we are looking at. As long as my left is less than or equal to right, I have to perform an action where mid is actually left plus right minus 1. Okay, and then as I mentioned, row would be the mid divided by columns. That would give you the row in which the mid lies, and the column is actually mid divided by columns. Okay, if the target is greater than the cell which we are looking at, that means our target will actually lie in the remaining half. Okay, or else we will look it in the right half, in the left half. Okay, if the target is greater than the mid, that means we have to look at it in its right half, or else we have to look at it in its left half, or else we'll straight away, that means if both of these conditions did not satisfy, that means we've identified the target element and then we'll straight away return it. Okay, this is one approach. The other approach is to we can also identify, we can see in this particular row, we can check in this particular column, we can identify in which row the target lies. Okay, so given a target, we have to first identify in which row it belongs to. Okay, let's say the target is 11, then target lies in the first row. If target is 30, that means it will lies in the second row. If target is 3, that means it will lie in the first row, right? Given a target, looking at my first column, how can I identify in which row it belongs to? That means, let's say we have been given target as 10, and let's say this is the elements which we have to look at and identify the lower one. Okay, identify the first element which is actually less than or equal to 10. Okay, we have to find an index which is actually less than or equal to 10. This is also less than or equal to 10, but this is not the closest the highest index which is actually less than or equal to 10. 3 is also less than or equal to 10. 4 is also less than or equal to 10. 10 is actually less than or equal to 10. So this is the element which is the highest one and which is closest to 10. Okay, so we have to find that index. Okay, so what we'll do, whenever we found the mid, if mid is actually less than or equal to target, that means there is still a possibility that I can find a higher element which is actually closer to target. Okay, that means I have, this is my potential answer, my left would be mid, but still I will also include it in my search space because this could be my potential answer and I will search in the entire right half. Okay, if in other case I have to search in my left half. Okay, I won't be including the current bit and I will be searching the other half. Okay, and then every time I will be doing mid is equal to left plus right plus 1 because we want to go as far as to the right, which is actually satisfying the given condition. Okay, this would give us, on the first column, if you apply this particular algorithm, that would give you the element which is actually less than or equal to the target which we are looking at. Okay, for 3 it would give you the first row, for 11 it would be giving the second row. Now that you identify the row in which the target can potentially lie, on this particular row we have to apply the binary search. Okay, this is, once we identify the row, this is the regular binary search algorithm. On this particular row we have to apply. Okay, that would give you, that would actually tell you whether target was present or not. Okay, so these are the two approaches which came into my mind when I was trying to solve this problem. Okay, in both the approaches, okay, the time complexity will still remain the same, order of log mn, because in the first use case, in the single iteration, the total elements would be the order of mn. Okay, so the overall time complexity would be big of log of mn. Okay, whereas in this approach, the second approach, first we are identifying the lower bound. Okay, that which would actually take order of log, since the number of rows we have is m rows, so this would take order of m time complexity, and this would take order of n time complexity. The overall time complexity would be order of n plus m, which will be, sorry, order of log m plus order of log n, which would be equal to order of log mn. Okay, this would take order of log m because it has m elements and we are doing binary search on m elements, which would be order of log m. Okay, since it has m elements, and this is taking an order of log n because it has n elements. Okay, so the overall time complexity would be this plus this, which will be order of log m into n, which is equal to the required time complexity. Okay, yeah, that's all about this problem. Let me submit this. This should actually work. Yeah, it is working and it is pretty efficient. It has, in runtime, it has beat almost all the solutions. Yeah, that's all about this problem. Do subscribe to my coding channel for more such coding videos. I've noticed that people are not subscribing to my channel but watching my videos. I highly recommend you to subscribe so that you won't miss the content which I will be posting on daily basis. Yeah, let's grow together and let's upskill ourselves on daily basis. Thank you.